times time here. So we have two equations and two unknowns. Does that look right to you?
Yes.
Although I dislike that it says 5 times the time. Okay, so we actually have to make a small adjustment here. The t here is actually 5t because it says 5 times the time.
Yeah.
Okay. Now, you have two equations, two unknowns. You can in principle solve this for sure every time. How do you like to solve this?
So the way that we currently do is quite clunky, but basically you write out looks like 5 equations in this one. So you write again the distances, you write you know, a time compares. So here it'd be TD equals 5 TE, right? And then the rate is going to be RD, R with the subscript or D equals R with the subscript D plus 10. So yeah.
But that's too much because you basically, I'm asking you, like, you want to substitute for one variable or the other.
Yeah.
And your choice is either T is 120 over R or R is 120 over T. And I'm saying we just need to solve for one of these. And do you have a preference, I guess, is what I was asking.
No.
Okay. Now the answer could be, well, we have to find both the rates and times, so actually it doesn't matter. But let's just say just wanted the rate, you would use the t because then it would have the rate in there. But since we have to do both, well, it doesn't really matter. So 900 equals R plus 10, 5 times 120 over R. Now, a few things you can do to make this go faster is the R can be moved over here. And 5 times 120 is 600. And that 600 is gonna cancel with the 900. We're gonna deal with that right quick here. So if you divide both sides by the 600, that gives you 3/2, or 9 over 6, which is 3/2, equals R plus 10 over R. And from here you would cross multiply. So you get 3R equals 2 times R plus 10. And you would solve this. 3R equals 2R plus 20. R equals 20.
Gotcha. Okay.
Okay, so you got to do some things to make this like better to start out. Now R equals 20 is only part of it. We got to go back and find the t. T equals 120 over R, which is 6.
Yep.
I guess hours, like that. And then R, we probably should give units kph.
Yeah.
But that's hang on. So we got to be careful here. That is E's information.
Yeah.
We actually want Darnley's. So they really make this like you got to go back and back. So the time of D is 5 times the T. And then the rate is that rate plus 10. So you're still not even, like, the information I just found is for E. E's rate is 20 and his time is 6 hours. D's is 10 more than that. So his rate is 20 plus 10, which is 30. And T's time is 5 times the 6, which is also 30.
All right. Good. Got it.
All right. So I do see that the other one came through here. This time all the pages are there, although the second page, 8, 10, and 11 are a little tough for me to see, but
okay.
Where are we going from here?
Okay. You said 8, 10, and
11.
Okay. All right.
If you need help with those, you'll just have to give me the numbers.
All right. Sounds good. Okay. I guess question number 9.
Okay.
Yeah. Yeah, that'd be helpful.
All right. So this one, is that right?
Yes.
All right. So the first thing you're supposed to do is you're supposed to restrict the domain. Okay, so the idea here is that s needs to be greater than or equal to 0, and s plus 8 has to be greater than or equal to 0. Why did I set the part? Why did I set the s greater than or equal to 0 and s plus 8 greater than or equal to 0? Why do you think?
Because it could be a negative number.
You cannot take the square root of a negative number, so your s has to be greater than or equal to -8. Okay, and it has to be greater than or equal to 0. So basically, these both have to be true. So your answer needs to be greater than or equal to 0.
Okay.
So if you get a negative number, that's not good. All right.
Mm-hmm.
All right. So we have some choices here. None of them are good. We can either square it as is, squaring both sides as is, or we can move it around so that it looks like this. Let me put this down here. Square root of s plus 8 equals 4 minus the square root of s, and we can square this one. I kind of like the second one, but I don't know if that's going to be uncomfortable. Just moving the square root of s plus 8 over to the left and square root of s to the right.
Uh-huh. Gotcha.
Is it okay if we work with this one down here?
Yes.
Okay, so the square undoes the square root. On the right here, you have to FOIL. You can't just do something that's illegal in math. You have to actually write this out. So it's 16 minus 2 square root of s plus s, like this.
Mm-hmm.
Is that okay? Is that clear?
Yes.
Great. So now the s's cancel. And we isolate the term with the root in it. So the term with the root in it is this -2 square root of s. So I'm going to move that left. I'm going to subtract the 8 right. So it looks like this 2 square root. I'm going to switch to cursive here, equals 8. Okay.
Okay.
Now, if the number in front of the square root goes evenly into the number or thing on the right, like there could be multiple terms on the right. If it goes in evenly, you do want to divide by it. So you really want this to be square root of s equals 4.
Yeah.
Rather than squaring the left and squaring the right, because that's what we do have to do next, it reduces the problem. So s equals
16.
16.
Okay. Very well.
This is a classic test, SAT, ACT question. You might see something like this, by the way.
Gotcha. All right. Next one I'd like help with is 11.
Okay, can you read 11?
Yes. A 2 Newton force and a 1 Newton force act on a point as shown. Find the resultant force. And that shows
Okay,
the
yeah, I got
two things.
it. Okay,
All right.
that's good enough. So, I mean, this is not a math question, it's a physics question. Have you taken
Mhm.
physics?
No.
Do you think you will take physics?
Probably not.
Okay. All right, so the idea here is that this vector in red can be broken up into its vertical and horizontal components. And
Mhm.
you do that using trigonometry. So the way that this works is if you were to take the sine of 40 degrees, okay, the sine of 40 degrees is the opposite over the adjacent.
Mhm.
All right, now in terms of that's the y and that's the x. Okay, so the y, I'm sorry, sine is, I'm sorry, this is completely wrong. Sine, it's opposite over hypotenuse.
Yep.
Okay, so in your problem, it's y over 2. Okay, so the y value is ends up being y equals 2 sine 40, but we have to assign it a direction. It's negative. It's negative because it's going down. We choose by convention that negative is down.
Mhm.
Is that okay?
Yes.
The x you're getting from cosine. So cosine of 40 is adjacent over hypotenuse. In this case, it's x over 2. So to solve for x, it's 2 cosine 40. Now, because the arrow points to the right, we keep it positive.
Mhm.
Is that okay?
Yes.
All right, now we do the same thing for the other one. We draw a triangle. Another right triangle, but this vector is broken up into a vertical and a horizontal component. Okay, and I know that since the drawing's since there's a lot going on here, let me redraw it here without all the other stuff.
Okay.
And we can again call it X and Y. If you don't like that, let me know, but yeah, that's okay. So the cosine of 45 is the adjacent over the hypotenuse. So that's X over 1. So X ends up equaling cosine 45. And it's already positive because it's going to the right. The sine of 45 is Y over 1. So Y is the sine of 45. It's already positive because it's moving up. Okay.
Okay.
So what you're doing is you're resolving the vectors into their components, X and Y components, and you can add the X's and you can add the Y's. So they would, in a physics class, they would say, okay, the resultant in the X direction is 2 cosine 40 plus cosine 45. The resultant in the Y direction is minus 2 sine 40 plus sine 45. Okay, so we're going to want to use the calculator to get some numbers here. Can you tell me what it asked for again? What does the problem actually ask for?
Find the resultant force.
Okay, we're almost there. So 2 times cosine D 40 so we'll go 2.24 newtons, the X direction and the Y direction. This one is minus 0.58 newtons in the Y direction. So the idea here is that if we're to draw a new vector, it's going 2.24 right and then minus 0.58 down. So
Mhm.
that resultant vector is this one. Notice it's the hypotenuse of the triangle. So the resultant vector is the square of the X, square of the Y, square rooted.
Mhm. Okay.
So it ends up being about 2.31 newtons. Does it
Alright.
ask for the angle or just the resultant?
Just the resultant, I believe.
Okay.
Okay. All right then. What next? Okay. 22 and 23.
22 and 23.
They're very similar.
Oh yeah.
No pun intended, of course.
Yeah, that's a good one. Do you know what kind of function skips leg day?
What kind?
A quadratic.
Wow.
Yeah. I can go all day.
Yeah, I believe it.
Yeah. All right. So similar triangles, what they really mean is the special triangle. So there's a reference triangle that you need to know for a 30, 60, 90 triangle. And the sooner you know this, the sooner you're going to be able to answer these questions. So you have to immediately map like what they have to this thing on the right. Okay. Now keep
Okay.
in mind that X is a reference X. Okay. It's not really X. It's just because if you don't like that, you can change it. But you set the known side equal to the reference side.
Okay.
It's very critical. Known to the reference. Okay, so you're literally setting 3 equal to x square root of 3, and you're going to solve for x. So to do that, you divide both sides by the square root of 3. On the left, you have to rationalize. You multiply the top and bottom by the square root of 3. So the result is 3 square root 3 over 3, which reduces to the square root of 3.
Okay.
Okay. Now here, just to be clear, what we have solved for is the reference x.
Mm-hmm.
Okay. The reference x is the short leg. Now it just so happens that it's the same x as over here, but that could be disguised in another problem. So when you get
Okay.
the x, you're getting the x of the reference triangle. It just happens to be the same.
Okay.
And sometimes these are better stated in words. So if you have the short leg, the hypotenuse is double the short leg. You have the short leg, y, the hypotenuse is double the short leg. Double the short leg is 2 square root 3.
Mm-hmm.
Any questions on that? Any follow-up?
No. So, yeah, that all makes sense to me.
So it looks like they give you one of each type of special triangle, which is the other one here is a 45, 45, 90. Okay, so and this one's drawn kind of awkwardly, but in a 45, 45, 90, the 2 legs are x and the hypotenuse is x root 2. So just like in the previous problem, you set the known side equal to the reference side. Known side equal to reference side. Square root of 3 equals x, like that. And you immediately know that the other leg is x as well. So a is also the square root of 3.
Mm-hmm.
Now b, the hypotenuse, if you go over to your reference triangle on the right here, the hypotenuse is your leg times the square root of 2. You take whatever the leg is and multiply it by the square root of 2. So b is the square root of 3 times the square root of 2, square root of 6. Yeah.
Gotcha.
Perfect.
Okay.
Sometimes the words mean more than the actual,
Yeah.
mechanics of it.
Mm-hmm. Okay. Very
Right.
well. Let's see. 29.
29.
Also, I have a hand warmer here, by the way. My desk is on the garage. If I turn on, can you hear it?
I cannot. And
Oh, that's good. All right, good. I had turned,
no, stay warm.
yeah, gotcha. I turned it off because I didn't want to make a bunch of noise, but that's good.
No, but please be comfortable. So find the equation of the line that passes through 5, 7 and has a slope of 1/5. Now from last time, you've basically said, hey, Matthew, we've got to always put it in this form right here.
Yeah.
I would never, ever write it in this form to start, but it doesn't mean that that's wrong. I would actually start with point slope form and then simplify to that one, but that's up to you. You can tell me
Mm-hmm.
that you don't want to do it, but this is how I would start on the right. I would write the point slope form. I would substitute the numbers, and then I would solve for y. If you don't like that, we can work it on the way on the left. You tell me what you would like to do.
Since it's required to be turned in the way on the left, then we probably ought to do that.
The one on the left here.
Mm-hmm.
Okay. And just to be clear though, when I solve for y, it's going to be the same. It's going to be y equals whatever, but okay. So your slope is 1/5. Okay. And your b value is unknown. So you use this x and y to find it. 7 equals 1/5 times 5 plus b. 1/5 times 5 is 1. Okay. And then you subtract 1 from both sides. So b is 6. And that goes back into this equation right here. Y equals 1/5 x plus 6, and there's no like perpendicular or parallel stuff we were doing last time.
Yeah. Yep. Okay. Very well. All right. So
No,
those are,
I should have mentioned this earlier. I have worksheets that we could work on for 22 and 23 if you want to do more of those, but we can obviously do whatever you want, which is if you want to work through the assignment, that's fine.
yeah, sure. We can do that. I don't see anything
It's
else
up
in
to
here
you.
that I
I
think I'll
mean,
struggle with.
are you sure? Because I'm sure
Yeah.
maybe getting this off your plate would be good. I don't know. But yeah, let me really quickly pull up. May only take a few minutes anyway to go through these. Okay. Sheets. All right, let's do 45, 45, 90s first. All right, here we go. All right, so first of all, why is this a 45, 45, 90 triangle? What is it that makes it a 45, 45, 90?
Because one of the angles is 90 degrees and the other two are equal.
That's right. Okay, so the reference triangle here, whoa, is that this is x, and this is x root 2. Which one are they giving you in this problem?
They're giving us H and G or G.
G. This is the square root of 8.
Square root of 8. Yeah.
So you set the known side, square root of 8 equal to the reference side, okay?
Mm-hmm.
And then you multiply by square root of 2 to get the h value.
Yeah.
Okay, so could you try that for us, please? Get that.
Okay. Is that 4?
Yes, that one worked out really nice just to start out. Okay,
Mhm.
so go in the other direction. This one I think is the harder one. Is if they give you the hypotenuse, what do you do? Okay, so let me grab one of these that's like that. So the 45, 45, 90 are substantially easier than 30, 60, 90, but you still have to know what to do when you see one like this. So again, this one is a 45, 45, 90 because of the right angle, and they give you the 45. Here they're giving you the hypotenuse. So like, again, if you need it, I like to draw it every time, that reference triangle, x root 2. Gets you into a good habit for the harder ones, the 30, 60, 90s.
Good. So X will just, or so C will just be 6 times the square root of 2.
C is 6.
Yeah, right.
But
Sorry.
x might be something else. X is so you want to set the known side equal to the reference side.
Mm-hmm.
You want to set this 6 equal to this and solve for x.
Okay. So that'll be 6 divided by the square root of 2 equals X.
Yes,
Or
but you can't leave it like that. That's
yeah,
very bad.
Yeah, that's the reference.
That's it's got to be rationalized. That's what I was referring to. It's
Yeah. So then you multiply both ends by like both the numerator and the denominator by square root of 2,
yes.
and that will be X equals 6 6 times the square root of 2 over 2. which will cancel out to 3 times the square root of 2.
Good.
So,
No. Now, in this case, x is b.
mhm. So then b will be 3 times the square root of 2.
Yes.
And the other side will also be that as well.
Yes. Okay, so let's see if you can do one start to finish here without any assistance. And then we'll move to the more difficult ones.
All right. Okay. Okay. Right. Okay, so 10 times the square root of 2 is going to be equal to x, and then that will be equal to a.
Very good. Very good. All right, so just a final, I guess, maybe more challenging problem here. All right, so this time, giving you the hypotenuse there, just like the other ones. I'm giving you the x root 2 side. Okay, and we're saying that h is 11 square root of 14. So you set those equal. You set 11 square root 14 equal to x root 2, and you divide both sides by the square root of 2. Do you remember how to simplify the roots in this form?
Multiply both by square root of 2.
So there, because it's you could do that, but that creates additional work for you. It's like this: the square root of a over the square root of b becomes the square root of a over b. And the
Okay.
reason you would tend towards that is because 14 is divisible by 2.
Okay.
So this becomes 11 square root 7.
Okay.
Is that okay?
Yes.
All right. Okay, now let's start with the most basic type of 30, 60, 90 triangle that you can get. And that is where I give you the short leg. Okay, the short leg unlocks everything in a 30, 60, 90 triangle. So would you confirm for me why I'm giving you the short leg, or what is it about this picture that tells you that I'm giving you the short leg? So let me clarify, because the short leg is across from the 30.
Mhm.
Always. The short leg is across from the 30.
Okay.
So there you get you've taken geometry.
Euclid's, yeah. I
Okay.
did that for a year, but
Okay.
not the modern type.
Well, then it still applies. No matter the triangle, the smallest angle corresponds to the smallest side,
Yes.
and largest angle, largest side. So in the 30, 60, 90, you got the short leg x, great. You double it to get the hypotenuse, and you multiply by the square root of 3 to get the long leg.
So it's
So like
easiest to solve for.
it's the best case, because short leg leads to hypotenuse because you multiply by 2. Short leg leads to long leg because you multiply by the square root of 3.
Mhm.
It unlocks everything.
Okay.
Okay. So in this example here, can you tell me B and C or C and then B based on this
Yes.
drawing?
C will be 14. And then B will be 7 times the square root of 3.
Good. Okay. Now, the only way I can make this more difficult is to make the numbers more difficult. Okay. And I'm going to do that now. But you still want to draw that reference triangle every time next to it. Really will help here. Okay. So again, that short leg is X, hypotenuse is 2X, long leg is X root 3. All right, so go ahead and solve for A and B for me, please.
Okay. Okay. So 18 times the square root of 5 equals A.
Okay,
And then 9 times the square root of 15 equals B.
good, very good. Okay, now the next type of problem that you might get is one where I give you the hypotenuse first. So why would giving you the hypotenuse be useful? What can you
Because
immediately find once you get the hypotenuse?
once you get the hypotenuse, you can get the adjacent, or sorry, opposite.
Short
by
leg, short
dividing it
leg,
by half.
short
Yeah,
leg.
short leg, dividing it by half. And then the
You get the
adjacent
long leg
uh, by that.
multiplying by the square root of 3.
Yeah.
So see how that path, you have to get a short leg to get the long leg.
Mhm.
Okay, so here's one for you to consider. And then we'll increase the difficulty a little bit here.
So uh, okay. So X equals 5. So A is going to be 5.
Okay,
And then B will be 5 times the square root of 3.
very good. All right, so pretty straightforward. But you don't always get nice numbers to work with, especially in your class, right?
Yeah.
So you shouldn't expect that. Now, the most difficult type is when I give you the long leg, right? The long leg is the absolute worst. We'll see why in a moment here. Okay, so here's a problem for us to look at. The long leg has a square root of 3 in it. And that's typically where you got, something to do here. So it's X, 2X, X root 3. And this problem, they're saying G equals 6 square root of 2. So you're setting 6 square root of 2 equal to X root 3. Okay. And
Mhm.
just like before, we gotta solve for X. So we gotta divide by square root of 3. Now this time you do rationalize because 2 doesn't go into 3, or you can't divide by 3 and get a nice number. So
Mhm.
you multiply the top and bottom by square root of 3.
Okay.
So that becomes 6 square root 6 over 3 becomes 2 square root of 6 equals
X.
X. Okay, so when you get the long leg, you have to find the short leg, which is you effectively divide by the square root of 3, and then you can find the hypotenuse by multiplying by 2. So once you find that this is 2 square root 6, you double it, 4 square root 6 for the hypotenuse. So if you understood that, I'd like to give you one to try
Yes.
here on your own.
Okay.
Same difficulty, then we'll see if we need to go beyond that. I'll give you the other awful things they do and here, but go ahead and take a look at that one.
Okay. Okay. R is going to be 3 times the square root of 15, and then 2 will be 6 times the square root of 15.
Okay. That sounds perfect. So what could you see here? So what they will occasionally do is they'll give you a problem like this. And this looks like the short leg. Would you agree?
Yes.
So what they will do is they will put a 60 here. And now this is no longer the short leg. And they'll tell you that this is 15. Okay. And then they'll make this really weird. They'll say find X. Okay. Being the hypotenuse. And that's really weird because X is not the hypotenuse most of the time. So they do these things to kind of disguise, be deceptive. But if you use the strategy I've been talking about the whole time, which you set the known side equal to the reference side. Okay, so this time it's the 15, which is the long leg, is equal to the x root 3. So if you always follow that strategy, even if they give you something weird, you will never have a problem when you're doing these. So 15 equals x root 3, divide by root 3, and you get 5 root 3 equals x. Now you have to be careful again because that's not x, that's the reference x. The x that they want is the hypotenuse. So you have to be careful here. And you know, if you don't like the x's, you can make them u's or something. I think we did that last week with a problem, some sort of substitution. So then you say, oh, well, x is really 2 times u because it's 2 times the short leg. Okay, so the x that they want in this problem is 2 times 5 square root 3 or 10 root 3. And all they're doing is just being deceptive with the letter choices there.
Yeah.
Okay. All right. Well, that's a really short thing on triangle stuff. You did great there. What else can I help you with today? Any other problems you want us to look at? We probably can do at least one more the time we got left.
I guess question number 10.
Okay, you're gonna have to read the system to me. So
Very well.
I see 2x minus y
plus 2z equals 3.
Okay.
X minus y minus 2, or sorry, minus 2z equals -6.
Okay.
And then 3x minus y equals 0.
Like this.
Yes.
All right, now a lot of ways to solve this, but the thing I'm immediately drawn to is the fact that it's plus 2z and minus 2z here.
Okay.
Okay, which means if you add these two equations together, the z is going to drop out.
Okay.
So we're going to add those together. I'm going to do it off to the right here. So it's 3x minus 2y equals 3. Let me know if you have any questions about that. You're just adding the equations together.
Wouldn't it be -3?
Yes. Good
Okay.
catch. I was gonna get to the end of the problem. It wasn't gonna work out nicely. Yeah, so now bring the other equation over.
Okay.
And
Okay.
from here, you
Okay.
go ahead.
I was just saying it would probably be best to, in the second equation, solve for y. So,
I was actually gonna suggest subtracting.
okay. All right.
And I like it. You can do that. I think you're the kind of math student you should get comfortable with subtracting. So it's 3x minus 3x, that's 0. Minus
Mhm.
2y minus a minus y, that becomes minus y. Minus 3 minus 0 is minus 3, y equals 3.
Okay.
And then we can use any equation that we were just looking at up here to solve for x. Let's use that second one. 3x minus y equals 0. So 3x minus 3 equals 0. You'll solve and find that x equals 1. When you do that, now we're really in good shape. We got x and y. So we can go back to any of the original equations. I'll go with the first one. So
Okay.
2x minus y plus 2z equals 3. And just substitute in those numbers we found. 2 times 1 minus 3 plus 2z equals 3. -1 plus 2z equals 3. Add 1. So z equals 2.
Gotcha.
So your answer is 1, 3, 2. You could check that in all three equations, should work.
Okay.
Probably would check the back of the book first before I did that.
Mm-hmm.
Oh.
All right. Yeah, I think that's everything.
Great. Let me go ahead and stop the recording here.